Hello everyone. Welcome to the session on OSI and TCP/IP model. In this session, we are going to cover OSI model, data encapsulation, protocol data unit and layer addressing, TCP/IP model. Ever wondered how devices communicate seamlessly across the internet? It all comes down to two key models, OSI and TCP/IP. The OSI model breaks networking into 7 structured layers, making it easier to design, troubleshoot, and understand how data moves. On the other hand, the TCP/IP model focuses on real-world implementation with 4 layers, ensuring reliable internet communication. In this lesson, we'll dive into their structure, functions, and the key protocols that power modern networking. The Open System Interconnection Model is a conceptual framework that standardizes communication functions within a network. It organizes the process into 7 distinct layers, each with specific technical responsibilities, enabling interoperability between hardware and software from various vendors. Layer 1, the physical layer. It focuses on the transmission and reception of raw bits. It defines electrical signals, voltage levels, and the physical interfaces for network hardware. Devices like hubs and network interface cards operate here. Layer 2, the data link layer. It ensures error-free node-to-node communication within a local network. It encapsulates packets from the network layer into frames and appends source and destination MAC addresses for precise delivery. Layer 3, the network layer. It is the backbone of inter-network communication. It handles logical addressing with IP protocols, both IPv4 and IPv6, and determines optimal paths for packet delivery using routing algorithms. Layer 4, the transport layer. It ensures end-to-end data integrity and reliability. Using TCP, it performs segmentation, sequencing, and error correction for robust data delivery. For speed-centric tasks like video streaming, UDP provides faster connection-less communication. Layer 5, the session layer. It synchronizes communication between devices. It establishes, maintains, and terminates sessions, ensuring seamless data flow in tasks such as database queries or file downloads. This layer's protocols manage session checkpoints to recover from disruptions. Layer 6, the presentation layer. It acts as the translator of the OSI model. It handles data formatting, encryption for secure transmission, and compression to optimize bandwidth. Protocols like SSL and TLS operate here. Layer 7, the application layer. It provides network services directly to end-user applications. It supports protocols like HTTP for web browsing, SMTP for email, and DNS for domain name resolution. Next, let's talk about data encapsulation. When a host sends data across a network to another device, the data undergoes encapsulation. This means that additional protocol information is added at each layer of the OSI model to ensure smooth communication. Each layer of the OSI model communicates only with its corresponding layer on the receiving device. This exchange happens using protocol data units or PDUs. Let's break it down according to the diagram. At the application layer, user data is generated. As it moves down the layers, headers like TCP/IP and MAC are added. Finally, at the physical layer, the data is converted into bits for transmission. Let's look into protocol data unit and layer addressing. Segment section. Data moves through different layers of the OSI model. At the transport layer, data is divided into segments. Each segment contains a source port and a destination port, which help identify the sending and receiving applications. Packet section. At the network layer, the segment is encapsulated into a packet. Here, the packet contains first, source IP and destination IP to determine the sender and receiver. Second, a protocol field specifying whether it's a TCP or UDP. Frame section. Moving down to the data link layer, the packet is wrapped into a frame. The frame includes first, source MAC and destination MAC addresses for physical device identification. Second, an ether type field for identifying the protocol. Third, frame check sequence for error detection. Finally, at the physical layer, everything is converted into bits, a series of zeros and ones ready for transmission over the network. Now, let's see the layer-by-layer breakdown of the TCP/IP model. Layer 1. Network Interface. It defines hardware standards like Ethernet and Wi-Fi, managing local data encapsulation into frames for transmission. Layer 2. Internet. It facilitates packet routing using IP protocols, employing addressing schemes and error reporting through ICMP. Layer 3. Transport. It manages process-to-process communication with TCP and UDP. It implements error detection, flow control, and congestion control for reliable data transmission. Layer 4. Application. It combines OSI's top 3 layers, supporting protocols like HTTPS, FTP, and DNS to handle web services, file transfers, and domain resolution. Thank you for watching.